Fourth grade lesson 9.7 is compare decimals. I think you'll find this one fairly easy once it's shown how to do it. Let's get started. The essential question is, how can you compare decimals? Let's unlock the problem. The city park covers 64 hundredths square mile. About 18 hundredths of the park is covered by water, and about 2/10 of the park is covered by paved walkways. Is more of the park covered by water or paved parkways? So we cross out unnecessary information, can be a helpful skill for us, so let's do that first. Since they're asking only what is more of the park covered by, I don't really need the whole size of the park because that's not part of what they're asking. Maybe if they ask me a different question later, I'll need that again. But right now they just want me to really compare the park that's covered by water and the part that's covered by pathway. So I need to find which is more the parkway, the walkway, I guess I should say, parkway or walkway, or water. That's what I need to find. And the numbers I need to use were the 0.18 or 18 hundredths and 0.2, the 2/10. Okay, visually they're going to show that to us first, and then we'll talk about this too. They want me to shade in 18 hundredths, so we have that split into hundredths, and we're doing 18 of those. So there's 10 and then 8 more, there's 18 hundredths. On this one, the amount that is covered by covered walkways, or covered by paved walkways, I should say, is 2/10. So we would split this into tenths and shade in 2 of those tenths. And when you do that visually, you could see that this one is a little bit more than that one. Even though in our brains are saying, wait, 18's more than 2. But this is 18 hundredths cut into 100 pieces. Those are tiny pieces, and 2/10. So 2/10 is greater than 18 hundredths. You could also think of that in terms of money. Again, decimals is what our money system is based off of, so let's tack that knowledge on to money. If you have 1 dime and 8 pennies, or here you have 2 dimes, 2/10, 2/10, 2 dimes is more than 1 dime and 8 pennies, right? Just a little bit more, but it's more. So you can tack that onto money, that information onto money, and that should help you too. Another way they give us, aside from those two, the model and relating it to money, is using a number line. If we locate 18 hundredths and 2/10 on a number line, where would we be? Well, remember, we are narrowed in. This is 0 and a little more, 0 and a little more. So we're narrowed in on the number line between 0 and 1 whole. In fact, they even narrowed us in further. They did 0 and a half. So this number line technically would continue out, and we would have 1 over here, 1.0. So we're really zoomed in to between 0 and 1, and they zoomed us in even more to here. So if we have 18 hundredths, we would split between 0 and 1 into 100 pieces, and that's why they didn't do it on here, because it would just be so long. So 100 pieces, and I need to step across 18 of those little 100 hash marks. So there's 10, 11, 12, 13, 14, 15, 16, 17, 18. I land about right here for 0.18. If I'm doing 2/10, that means between 0 and 1 is now split into 10 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces. And I'm going to cross across 2 of those 10 equal pieces. 1, 2. And that lands me right here. So they're super close to one another, and in your brain you're probably making that connection. This is 18 cents and this is 20 cents. It's almost the same amount, but this one is slightly smaller. 18 cents is a little bit smaller than 20 cents. So since 0.18 or 18 hundredths is closer to 0, 0.18 or 18 hundredths is, oopsie whoopsie, that should be the other way around, is less than 2/10. 18 cents is less than 20 cents, right? Than 2 dimes. Okay. Compare equal sized parts. 0.18 or 18 hundredths is 18 hundredths. And instead of calling this 2/10, let's make it 20 hundredths. Let's put that 0 on the end to make it a 20 that ends in the hundredths place. 20 hundredths. So now that we have compared the equal parts 18 hundredths, now we've got, it's like having a common denominator, right? That is exactly what this is, hundredths and hundredths. To compare them, we want a common denominator. We're just putting it as a word. 18 hundredths compared to 20 hundredths. Oh, okay, now that we have the same breakdown, then we know 18 hundredths is smaller than 20 hundredths. So 0.18 or 18 hundredths is smaller than 0.2 or 2 tenths. So more of the park is covered by the 0.2, which is the paved walkways. Probably that's starting to click a little bit, maybe a little foggy. Let's look at one more example. You can compare numbers written as decimals by using place value. Comparing decimals is like comparing whole numbers. So it's that same skill when we compared like the number 12 to the number 20. It's the same. It's just you just have to be real familiar with where things fall. Always compare the digits in the greatest place value position first. So let me just do a quick review. If I'm not comparing decimals and I want to compare the number 25, like $25, to the number 32, like $32, we always were starting in the greatest place to see which is bigger. These are $10 bills, right? So this is ones place and this is tens place. Well, I know that 3 tens is more than 2 tens, so now I automatically know that 32 is more than 25. They have more tens, okay? If it was the same amount of tens, let's say it was 25 and 22, then if it's the same amount of tens, then I move over to the next smaller place value, the ones place, and I compare that, and 5 is more than 2. So 25 is more than 22. That's something you're pretty automatic on by now. I want to tell you that in decimals, it's still the same concept. The greater values are still to the left, and the smaller place values, the more you're cutting it up, is to the right. So we still got to move across that way. So we'll see that happen. Tim has 5/10 of a dollar, and Sienna has 5/100ths of a dollar. Who has more money? And probably you're starting to see these now, some of you, and some of you may need to visualize it still a little more. Let's take Tim's money. Okay, let's take Tim's money. He has 5/10 of a dollar, so we cut that into tenths, and we highlight 5 of those 10. 1, 2, 3, 4, 5. Also, think about money. This is 5/10 or 5 dimes, 50 cents, right? 5 dimes. Sienna has 5/100ths of a dollar, so we have to cut her dollar into 100 tiny pieces, and we only get to use 5 of those. 1, 2, 3, 4, 5. And when you visualize that, wow, what a difference. He has a whole lot more, right, than she does. And think about this as money. Hundredths place is pennies. She has 5 pennies. He has 5 dimes. She has 5 pennies, right? Okay, so we have Tim having 0 ones, no $1 bills, 5/10, and nothing in the hundredths place. Sienna has 0 ones. She has nothing in the tenths place and 5 in the hundredths place. So if we were comparing, just like we did up here, if we're going to compare them, we start in the greatest place value shown, in this case 0. That's the same move to the next one. Ooh, that's more than that. So we can stop there and say, Tim has more. So 5/10 is more than 0/10, right? 5/10 is more than 0/10. So that means that these 5/10 is more than this 0/10 here. Even though she had 5 pennies, it doesn't matter. She doesn't have any tenths. So, and visually there it is. So Tim has more money. He has 50 cents as opposed to Sienna's 5 cents. They tell us to compare the size of 1/10 to the size of 1/100th. How could this help you compare 5/10 to 5/100ths? Well, the 1/10 is in comparison to 1/100th is much bigger. Remember, these are 10 times more. So those rods are 10 of the hundredths ones. So the tenths place is 10 times more than the hundredths place. So there's our comparison between the two. Let's have a look at this comparison. We're doing 1 3/10 to 0 6/10. Which one's greater or less, or are they equal? Well, let's start by the modeling method. Then we'll talk about it in terms of place values, and then we'll talk about it in terms of money as well. Let's shade in one hole. Okay, so we have one hole. Okay, that's shaded in the lines, okay. And then 3 out of 10. So this is broken into 10 equal pieces, and we're going to shade in 3 out of the 10. There we go. Okay. Now let's go over here. We have 0, 0, and 6/10. So we have 6/10. This is split into tenths, and we're going to shade in 6 of those. 3, 4, 5, 6. Okay. Which one has more shaded in? Clearly this one does. So 1.3 or 1 3/10 is more than 0 6/10. Let's talk about it, comparing greater values as we move down from left to right. We always start when we're going to compare numbers on the left and move down the line until we find out which one's greater between them. And right away, our first value on the left, 1 is bigger than 0. So right away you could say, 1.3 is greater than 0.6 because 1 whole is bigger than 0 whole. So there is another way to do it. Now let's talk about it in terms of money. This is $1 full dollar and 3/10, 3 dimes. Let's just go ahead and call that 30 cents. 3 dimes is 30 cents. $1.30. And this is $0 and 6/10, or 6 dimes. We'll just call that 60 cents. $1.30 or 60 cents. Which one do you want? Well, the $1.30. That's more, right? So 3 ways to compare those, whichever attaches to your brain best, and then with practice you'll get to a point where you can see it pretty quickly. So let's practice some, and this is the point where again you can pause and play to check your answers just to see how well you're getting it when you feel ready to do that. Compare 39 hundredths and 42 hundredths, right, greater than, less than, or equal to, and you can shade the model to help. This time I'm going to go the other way around. I'm going to do the comparison to each other. I'm going to line them up one above the other. I'm going to start at the greatest value, 0 and 0. That's the same. Move to the next value, 3 and 4. 4/10 is more than 3/10. So this is the larger value. You stop as soon as one of them is larger than the other. That's the larger value. Alligator eats larger values. Ta-da. That's how you could do that by comparing place values. You could think of it like money, 39 cents and 42 cents. 42 cents is more than 39 cents. You can model it. This is 39 hundredths, so we have that broken into 100 equal pieces, and I need to shade 10, 20, 39 of them. Over here, this is 42 hundredths, so it's broken into 100 pieces, and I need to shade 10, 20, 30, 42 of them, and visually you can see this one is more than that. Let's compare 0.26 or 26 hundredths and 0.23 or 23 hundredths. We have 0 in the ones place, 2/10 and 6 hundredths, and over here we have 0 in the ones place, 2/10 and 3 hundredths. We start over here in the ones place, in the furthest, the highest value that's shown, the ones place. Those are equal, so move over to the next one. 2 and 2 are equal, so move over to the next one. 6 hundredths is more than 3 hundredths, so this is the higher value. You see how that's playing out? And again, you can ask yourself, that's 26 cents, that's 23 cents. 26 cents is a little bit more than 23 cents. Let's check this one. 0 and 7/10 or 0 and 54 cents. Which one is more? Let's line them up. 0 and 7/10 and 0 and 54 hundredths. Okay, I can go ahead and compare this place value. It's the same. Move to the next one. 7/10 is more than 5/10, so this one is more. And I know our brains want to rebel against that and say, wait, 54 is more than 7. Yes, but remember, we're on the other side. This is how much it's being chopped into. And think of 54 cents compared to 7 dimes. If you need to put that 0 hundredths there for your brain to catch that, put that there. It matters. Okay, so we have 70 cents as opposed to 54 cents. 7 dimes, 70 cents as opposed to 5 dimes and 4 pennies. This time we have $1.15, and we have $1.03, or one and 15 hundredths, 1 and 3/10. Let's put them on here. We have 1 and 15 hundredths, and we have 1 and 3/10. No hundredths on this one. I can put a 0 there for that. Let's go down the line and compare, starting on the furthest left. 1 and 1 are the same. Move to the tenths place. 1 and 3. Ooh, that's more. And $1.30, of course, is more than $1.15, or $1.03, 30 cents. More than $1 and 1 dime and 5 pennies. So 1.3, or 1 and 3/10, is the greater one. Last one, try it, and then push play. We have 4 and 5/10. We have 2 and 89 hundredths. This is 4 and 5 dimes. 5/10 is 5 dimes. That's 50 cents. So I'm going to go ahead and just put that 0 there for my brain. My brain likes it there. So that way they line up nicely. But right away we should notice, I didn't even need to do that really, right? Because if you compare $4 compared to $2 in the ones place, 4 is more than 2. If I was going to ask you want $4.50 or $2.89, well, the $4, of course, that's greater. Okay, and once you compare those and you find what's greater, you don't have to look at the rest. You can just say, oh, that one's bigger. That's all this lesson is. So hopefully you're good to go on this, and let me know if you need any help on your Think Central or any extra practice.